explorers today in the Gulf of Mexico. The frontier they're mapping lies fathoms deep. It is the submerged extension of Louisiana's coastal plain, which slopes seaward 100 miles and more. Under the mud of this continental shelf, more than 200 salt domes lie, waiting to be tapped for new supplies of oil, natural gas, and sulfur. The past few years have seen tremendous growth in the offshore fields, while drilling equipment and its massive foundation structures have pushed farther and farther out to sea. In the lead of this offshore march is J. Ray McDermott and Company, the pioneers in oil industry construction for more than 3 decades. This one company has been responsible for constructing most of the platforms in the Gulf today.
Rory, we're in pretty good shape out here this morning. We just finished setting the drag substructure. Ought to have all the heavy lifts made by first thing in the morning. Well, the weather's okay. We got a light wind and wave from the southeast. Barometer reading 30.15. Looks mighty good.
Long known as dependable and expert in its service to the oil industry on land, J. Ray McDermott has led the way in developing new structures and new construction methods in the marine field. Marine operations began for the company during the 1930s in the desolate coastal marshland. When the early drilling barges moved in, McDermott was at work deepening the choked-up bayous and dredging new canals to the drilling sites. These new oil fields called for new working tools. The company had to engineer a variety of heavy-duty equipment in order to meet all the jobs of the new industrial frontier. The design of an offshore structure has its beginning in a study of the soils which are going to hold it up. A test rig is sent to get borings at the future well site. In the Gulf, most of the silt and clays provide poor foundation. In the geological sense, they are still young, still soft and uncompacted. Boring samples are not only tested on the spot, but sent ashore for further laboratory analysis. McDermott relies on the work of top engineers who have years of experience in soils analysis. Their findings will tell the engineers how deep the piling must be driven, for support in these soils depends almost entirely on the skin friction between soil and pile surface. Designers must also take into account the frequency, direction, and velocity of major storms at the site. Storm tides, wave heights, and wave forces all enter into the design, as well as the vertical loads of the platform's own weight and drilling equipment. The proper use of this data has been learned the hard way, by work in the Gulf itself. McDermott men began with some of the earliest structures made, ocean platforms which rested on forests of wood piling and offered great lateral resistance to the sea. Fighting current, wind, and wave to align this piling was costly work. The first McDermott-type template put an end to this. It provided a rigid guide and pattern through which the piles could be stabbed and driven into the Gulf bottom. It also provided underwater lateral bracing, which was not previously feasible, right down to the ocean floor and sometimes down into it. The first pile diameter was small, and it took a great many piles to hold up the deck load over each jacket. This multiplicity of piles and braces offered considerable lateral resistance to the seas. Continued refinement of design has led to fewer, much larger piles with wider spacing. While the Gulf area has seen a tremendous increase in exploration and production, J. Ray McDermott's growth has been even faster. This company can handle any job of marine oil field construction, any size, any time, anywhere. From headquarters on the Harvey Canal in Harvey, Louisiana, it directs operations extending from the Florida Keys to the Rio Grande.
That's right. Derrick 7 is on its way now. They figure around midnight. Yes, they'll be going right to the shipyard to start loading out those jackets.
Oil fields never sleep. Work is around the clock 7 days a week. New jobs don't wait till daylight. They start as soon as the equipment can get there. One such recent job was the construction of the biggest offshore platform ever made. The prefabricated steel deck sections each weighed some 240 tons. The templates themselves were 118 feet high, for the finished structure will stand far out in the Gulf in 97 feet of water. The template technique of building offshore drilling structures was originated and perfected by McDermott. M.B. Willey, the company's late chief engineer, designed the first jackets especially for cutting erection time to a minimum at the ocean site. Prefabricating deck and jacket sections in a shipyard on shore means that large units can be fabricated without exposing this work to the weather delays found in the open ocean. Deck planking is installed before the section leaves land. The steel framing has been protected from the elements by a special vinyl paint. Even stairways, railings, and the steel mesh lower deck are in place. Each barge load towed to the site carries one deck section and one template, with the deck sections being loaded first. Because of their unprecedented size, the jackets had to be constructed on their sides. But to save offshore working time, each must be loaded on the barge upright, ready to be lifted off and placed on the sea bottom. First, the 210-ton mass of steel columns and bracing is skidded carefully to the water's edge. Cover plates have been temporarily welded over the ends of the tubular columns to make them buoyant. Once the derrick has lifted the jacket, it has to move out into deep water, where the template can be lowered until it floats of its own accord. Now that it is afloat, the giant structure can be swung around, and the derrick is able to rotate it to the vertical. Clear of the water now, the template is held aloft while its barge is maneuvered underneath. The massive steel columns are welded to the barge deck to secure them for the 158-mile voyage to the drilling site. In the unprotected waters of the offshore fields, weather is always an enemy. The only effective defense against its sudden changes is detailed, precise, and dependable weather information. Several times a day, weather reports are broadcast to every crew, to all equipment, no matter where in the Gulf they may be. Although the company has facilities for both AM and FM broadcasting, it is FM, with its freedom from interference, which is used predominantly. Its range is extended beyond the normal limits from company headquarters at Harvey by rebroadcasting from the McDermott yard at Bayou Buff and from Diamond Island at any hour of day or night. The company can be in touch with crews at work far out on the continental shelf.
Aviation, weather, 8:30 a.m. observation. Visibility unrestricted. Strong northeast winds making exposed water landings difficult. Ceilings expected to lower gradually along Louisiana coast today. Occasional rain over area. The strong norther mentioned in this morning's report is now moving southeast 12 miles per hour past Monroe, Louisiana. It is expected to reach southwest Louisiana coast this afternoon. Wind expected to shift to north-northwest 35 to 45 miles per hour along the central and southwest Louisiana coast. Thunderstorms with strong gusts to 60 miles per hour may develop along the norther tonight. Saturday, decreasing westerly wind and waves. Clear skies, tides below normal. Good working conditions, East Bay. Improving working conditions, all other locations.
The units for the Continental platform on its way downriver to the Gulf make up a mammoth tow, 760 feet long. Handling big pieces for offshore jobs calls for big machinery. There were no derrick barges in existence satisfactory for work in the open sea until McDermott contracted for one to be built. None could provide the lift capacity and swing which is routine necessity in today's marine oil field work. In Block 47, at exactly this spot, the biggest drilling platform to date is about to be built. A lot of floating equipment is needed to erect it. The #1 construction tool of the McDermott outfit is the derrick barge. #7, the fourth of the company's big floating derricks, has a lift capacity of 250 tons at an 80-foot radius. The boom length is 200 feet. Now moored in the exact position indicated by the buoy, it puts most of that lift capacity to work, carefully lowering the giant steel jackets to the ocean floor. The derrick barge itself is as long as a football field. Such unprecedented size is for stability. The effects of waves and swells must be smoothed out as much as possible, for it takes only a little motion at the barge deck to create a wild swinging at the boom tip. Without a steady working platform, it would be impossible to spot piling in the jacket columns. With a sea running like this, it's tough enough anyway. The derrick can handle piles in single lengths of up to 220 feet. Using the longest lengths possible cuts down working time at sea. But the soils sometimes call for deeper penetration than can be reached with a maximum single length. So, additional lengths must be spliced on. Now, the 287-foot pile is penetrating 150 feet down into the silt and clay and can be marked for final cutoff. When all the tops are level, the structure is ready to receive the deck section. This fully contained drilling platform, when it is completed, will withstand tremendous forces of hurricane winds and waves. But now, before construction is even finished, the sea has already mounted its attack with more subtle weapons. Electrolysis immediately starts to corrode the metal below the surface. This can be controlled by hanging electrodes to which the electrolytic action is diverted. Above the surface, the steel is protected by special paints. But in the splash zone, that area of the jacket affected by changing tides, neither paints nor cathodic protection will help. Here, special sheathing like this Monel sleeve is necessary. When deck structures and drilling equipment have been installed, this job is over. Derrick 7 is moved on to the next one. At the steel island it leaves behind, drilling begins in a depth of water considered out of reach a few short years ago. Progress such as this is the dominant theme of offshore operations, and by helping make it possible, McDermott has held its position as leader and offshore pioneer. Increased work volume has demanded still newer equipment. Another big derrick, number 8, was completed in 1955. Its hull, containing complete quarter 2, was so big it had to be built in 2 sections and then joined. Even before number 8 was launched, construction began on number 9. This huge American derrick has a normal lift of 250 tons, but for special jobs, auxiliary lifting equipment will give number 9 a capacity of 800 tons. This company sees no letdown in the mushrooming growth of the offshore fields. It expects at least 50 years of even greater expansion and is ready for it. McDermott's men have know-how and experience in the marine fields, and they're proud of their reputation for pioneering in new methods and materials. Concrete, for instance, is comparatively new in offshore work, yet pre-stressed platforms like this may prove to be one answer to the always present corrosion problem. After many years of research, J. Ray McDermott, in conjunction with the Raymond Concrete Pile Company, has made and installed several pre-stressed concrete platforms in the waters of the Gulf. Their great strength lies in the large, hollow, pre-stressed concrete piling, 36 inches in diameter. Both piling and the reinforced concrete decks are prefabricated ashore. Once erected, they need no further maintenance. This gas compressor station being built at Duck Lake is another unique application of a pre-stressed concrete platform. Here at the Bayou Buff Yards, McDermott's partially owned subsidiary, the Gulf Pre-Stressed Concrete Company, loads out the longest concrete test pile ever made, 196 feet. By driving this pile and later test loading it, the engineers gathered valuable information for future pre-stressed concrete installations. McDermott has also figured in the development of the DeLong type of mobile drilling platform, a self-contained unit which can move from one drilling location and be completely set up on another in under 20 hours. The Offshore company, in which McDermott has an interest, is already operating 2 of these DeLong barges, and others are under construction. Whatever type of platform is needed, McDermott can build it. To date, farther and farther from the sight of land, most of the offshore platforms in the Gulf have been constructed by J. Ray McDermott and Company. Pioneers, offshore.